Recording started. Okay, let me share my screen. All right, so today's lecture, we will talk about the Jordanian electricity sector. So we will talk about the electricity overall in Jordan, about the sector, about the companies and who's governing or who's controlling the electricity right now. Um, let's talk a little bit before 1997. Before 1997, there was we call it GEA, which is the Jordan Electricity Authority, which is in Arabic called سلطة الكهرباء الأردنية. And there was also two other companies like JIPCO, which is Jordan Electric Power Company, which is شركة الكهرباء الأردنية, and ITCO, Irbid District Electric Company, شركة توزيع محافظة إربد. So we used to have like these three main major companies like Jordan Electrical Authority or سلطة الكهرباء الأردنية, which was controlling, everything. So it was the generation, GEA. It was responsible about the generation, about transmission, and about part of the distribution, not all of its parts of distribution. And in addition to this, it was the system operator. They were controlling the electricity in Jordan. So there is the control room, the system operator, the control room in there, which was controlling the whole electricity in Jordan, which tells the generation company when to be turned on, when to be turned off, and also buy power from generation and sell it to the distribution. So again, the GEA was controlling everything that was before 1997, and the government were responsible about everything about the MIMER. So MIMER, which is called Ministry of Energy and Mineral Resources, وزارة الطاقة والثروة المعدنية. So GEA was owned by the governments. So they were controlling everything that was before 1997. But after that, what's happening, which is basically in 1994, the Jordanian cabinet took a decision to restructure the GEA. They took the decision and they were trying to figure out how to do it. So in 1996, the General Electric Law, there was a decision to separate the GEA into three companies, and they applied it in 1997. So GEA was split into three companies. سلطة الكهرباء الأردنية was split into three companies. The first company, the National Electric Power Company, which is NIPCO, and this is responsible for transmission and the system operator. It's the system operator. And just give me a sec. I'll be back in a minute, just a moment. I'm sorry, there was a technical issue. I just solved it. I'm sorry, I apologize about it. Let me go back. Let me share my screen again. All right, let's go back here. So GEA was split into three companies: NIPCO, شركة الكهرباء الوطنية. Again, GEA is سلطة الكهرباء الأردنية. So it was responsible for transmission, and it was the system operator as well. Then the other company, the second company, the Central Electricity Generation Company, that was responsible for generation. Then the last one, which is Electricity Distribution Company, EDCO, this is for distribution. So it was split into three: transmission, generation, and distribution. And they let the system operator, let NIPCO to be the system operator. So NIPCO is controlling. The control room is with NIPCO, and they are controlling the whole electricity. So again, NIPCO is called National Electric Power Company, شركة الكهرباء الأردنية. The Central Electricity Generation Company, SECCO, which is شركة توليد الكهرباء المركزية, and the Electricity Distribution Company, which is شركة توزيع الكهرباء. So they was split into three companies. Now here is the new structure. So in this new structure, they realized that they said like the generation might not only be associated with SECCO, they allow more than one generation company. More than one generation company. So now SECCO is one of those. So there is a SECCO and there is more. So they allow to establish a new companies for generation. However, in transmission, it's only NIPCO. Only NIPCO. No other company. Anything related to transmission, anything related to the system operator, it's only with NIPCO. No other companies is allowed. The other thing, the generation, the distribution, we have three: ITCO, GIPCO, ITCO. Now we have a lot of companies. Therefore, the Ministry of Mineral Resources, MIMR, in order to handle and regulate everything, they established a new commission, which is Energy and Mineral Resources Commission, which is, we call it هيئة تنظيم قطاع الطاقة والثروة المعدنية. So the first thing is وزارة الطاقة والثروة المعدنية MIMR, وزارة الطاقة والثروة المعدنية. And the other thing, هيئة تنظيم قطاع الطاقة, Energy and Mineral Resources Commission. هيئة تنظيم قطاع الطاقة والمعادن. So I believe in 2012 it becomes as Energy and Mineral Resources Commission, so EMRC. In the past, I think before 2012, it was called ERC without the word mineral. So it was called هيئة تنظيم قطاع الطاقة alone, without المعادن. Then they restructured it to be EMRC, Energy and Mineral Resources Commissions. Then why they established this? So we need to have, we need to have something like in the government that are controlling all of these companies. We have many generation companies, we have distribution companies, and the transmission company. We need, a commission that can control or give the regulations for all of these companies. So assume, for example, you are a member of GIPCO. You are a customer of GIPCO actually, and you file a complaint about GIPCO. So let's assume that GIPCO give you, a very large or a very big, your bill is very big, more than expected, like for example, like very, very large value. Then you need to file a complaint. After you file a complaint with GIPCO, they said, for example, we will not consider your complaint, everything is okay. Then you know there's something wrong. You still insist there's something wrong with GIPCO, but they are not listening to you. So what you need to do is you can file a complaint to the EMRC. EMRC, they will follow up with them, and they will, if you have rights, if under the law, under the rules, then they will follow this. They will make sure GIPCO will follow the rules. So I mean, EMRC is, they are just observing and controlling the other companies, make sure they are following the laws according to the electricity laws and the tariffs, etc. Then again, to the structure, we have MIMER, then EMRC, then after that NIPCO, which is the system operator. Then we have the generation companies and distribution companies. So again, AITCO, شركة كهرباء محافظة إربد, is associated with the north. GIPCO is associated with the middle. AITCO is associated with the south, ITCO, associated with the south, but not only the south, it's also Jordan Valley, and also associated with Azraq and Safawi. So it's not only about the south, it's yes, the south, but you can add to it Jordan Valley and Azraq and Safawi. So that's the thing that you need to keep in mind. GIPCO, which is شركة التوزيع الأردنية, while GIPCO شركة الكهرباء الأردنية. AITCO شركة كهرباء محافظة إربد. NIPCO شركة الكهرباء الوطنية. So the thing here, you need to be familiar with all of these companies and understand and distinguish. SITCO شركة التوليد المركزية. Okay, that's the companies that you need to figure out. Now, NIPCO, again, the purpose of NIPCO here is like the NIPCO, and this is the logo of NIPCO. NIPCO is responsible for, generation, which is basically will buy power from the generation companies and sell it to the distribution. No other company is allowed to do that. Nobody can buy power directly from the generation company. Nobody or no any institution or any industrial area or nothing. They are not allowed to buy power from the generation. You need to buy it through NIPCO. So if you need to buy power, NIPCO will buy power for you from the generation and sell it to you. So NIPCO will supply power, will sell power. It sells power to the distribution companies and also will sell power to the very large customers. As an example, for very large customers like phosphates, I think Smint al-Rajhi, and I believe also the Botas. Those are as an example of large customers that NIPCO sell them directly. Other than that, like for example, like Al-Muwaggar industrial area or Al-Hassan industrial area in Irbid. So all of these Jarash industrial areas, these industrial areas, they will buy power or from the distribution company, not from NIPCO, because they are not considered as a large. Yes, they are industrial areas, but those are not very large values. Then the very large values like phosphates, cement, the potash, those are very large, very huge value of power. Then they will buy power from NIPCO. While the rest, there are just few customers buying power from NIPCO, while the rest, they are buying power from the distribution companies. So the thing, again, NIPCO will buy power from the generation companies, no matter, it's not only SITCO, from the rest, all of the generation companies, and they will sell it to the distribution and very large customers with the tariffs. Then, if you need to buy power for your home or for your market or for the mall, shopping mall, or to the industrial area, which is called customers. So distribution companies like NIPCO, like AITCO or ITCO or GIPCO, they will buy power from NIPCO, or NIPCO will sell power to them. Then NIPCO or the distribution companies, they will sell you power. So distribution companies will sell the industrial areas, sell the malls with this amount of power. Okay? That's, I mean, the structure. So in order to get power, so you have SITCO and you have other generation companies. NIPCO will buy it and sell it, let's assume to GIPCO. Then GIPCO will sell it to GJU. So GJU will buy power. GIPCO cannot buy power directly from SITCO. They cannot. Even though, let's assume there is, there is a power plant in Gatrani, a power generation. You cannot buy power, Gatrani, sell power directly to GJU. They are not allowed to do that. You need to buy power from GIPCO. GIPCO will buy power from NIPCO. NIPCO will buy power from SITCO. It must go through this structure. Okay, that's the thing. That's the the responsibility. That's the structure for power. And the other thing, NIPCO has other responsibility like system operator. It's not only buying power. It's not only transmission. It's also transmission as well. System operator and this transmission through it. So the transmission, keep in mind the transmission, the main that we mean by the transmission, high voltage and extra high voltage. However, medium voltage is considered sub-transmission and it's part of the distribution company. So in the transmission, we have high voltage, which is 132 kilovolts, and the extra high voltage, 400 kilovolts as well. All of them, they are associated with NIPCO, 132 and 400 kilovolts. And again, we mentioned about the single power buyer, single power buyer, which is, again, as I said, everything must go through NIPCO. Then the next thing, again, system operator, which is we have the control room. The control room, they will tell the generation company when to turn on, when to turn off. So they have a control in the generation company, and also they have a control in the distribution companies. If, for example, there is a power out, there is an outage of the generation and there is a shortage in the supplying the power, they have an access to do a load shedding and turn off the power on the distribution companies. So they have all of the access through the NIPCO, the control room. They will ask the generation company to be turned on and turned off. There is a department, it's called a production studies departments, and there is operation study departments. These two departments, they will tell the generation company when to turn on, when to turn off, and how much amount of power that we expect to see, to have. So they have something we call it also, they do load forecasting as well. They used to do it, as we mentioned in the previous lectures, like short-term and long-term load forecasting. So all of this comes with NIPCO. So NIPCO is more important than the rest of the companies. Again, here's like the structure. We have the MIMR, again, which is the Ministry of Energy and Mineral Resources. We have the ERC, again, they recalled it now EMRC. Then here is like number 1, MIMR. Number 2, EMRC. Number 3, NIPCO. That's the structure. Then after that, the other companies. So NIPCO, system operator, single power buyer, and transmission provider. Then we have GIPCO, ITCO, ITCO, the distribution. Then when we have a large customers like cements, like phosphates, and potash, etc., all of them will be with large customers. And like the other thing, the embedded generation, like the distribution generation associated with the photovoltaics panels associated with, for example, the GJU, or photovoltaics at Hashemite University, or the photovoltaics panel in Just Jordan University of Science and Technology. All of them, they are connected to the medium voltage, and then therefore they will be with the distribution companies. So again, distribution companies, they are associated with medium voltage and low voltage, which is 33 kilovolts, 11 kilovolts, and there is 66, I think very few lines, 66 kilovolts, while 0.4, low voltage 0.4 kilovolts. All of them, they will be with only distribution companies. While transmission, only with extra high voltage and high voltage. 400 kilovolts or 132 kilovolts. Okay? Here is again the structure. Now, just a thing that it's worth to mention that the companies, not all of the companies are owned by the governments. The only thing that going by the government, NIPCO, is owned by the governments. Samra, owned by the governments. Sichco, it was in the past owned by the government, but right now it is with the private sector. And there are more, generation companies, they are privates. They are no longer, they are just established as a private, while Sichco, no longer government, now with the privates. While the only two companies, electrical power companies that are owned by the government are Sibchco, توليد السمرة, محطة توليد السمرة الحرارية, and NIPCO. Those are the only two companies owned by the governments. They are owned by the governments, but they are treated as private. So because they have their own general executive manager, and they already have their own, just their own laws. The laws with NIPCO are different than the laws with the SIPCO, and different than the laws with the ministry. While MEMR and EMRC, those are by the Ministry of Energy and Mineral Resources. Okay, so again, if we ask like which company is governed by which company is owned by the governments, we can say NIPCO and SIPCO. However, the rest are not owned by the governments, no longer that. Now let's talk about the power grid. I think this power grid, I believe it's all like in 2018. That was the time that I quit my job at NIPCO. So I had this in 2018. Then the thing here, right now there's a lot of modifications on that, because here there should be more 400 kilovolts power lines that goes to Al-Attarat area, 400 kilovolts. And should be more substations in Jarash substation. I believe here, there should be Jarash substation. And there is Madaba substation as well here. It is new. It's supposed to be before the Gatrani. I believe it is here, Madaba substation. Those are new substations. They were not, at that time, before 2018, they were not here, but they established it new. Then here is, you can see, it looks like the human vines. So it's, here's like the heart, then it moves to the whole body. Then the same thing at the electricity, it goes to the whole body. So I believe it's like this, the 400 kilovolts, the new established line. In the Attarat area, goes to Attarat area, because here they can produce energy. Then that's how the electrical power grid, again in the past. And look at the international interconnection. The international interconnection, we used to have two lines with Syria. The first line, it goes from North Amman, in North Amman substation, North Amman, 400 kilovolt substation. It goes towards Syria through Mafraq and through Suwaida area, Suwaida, Mahafat Suwaida in Syria. And there is another one, this is 400 kilovolts. And there is another one from Irbid, Janub Irbid, it goes towards Syria, 230 kilovolts. So we have two lines for interconnection, international interconnection, 230 kilovolt and 400 kilovolts. But the thing, the 230 kilovolt, there was a lot of problems on that. Even before the Syrian civil war, before the Syrian conflict, there was a big problem on that. So they decided to turn off the power. That was before 2008, before the Syrian conflict. So right now, it no longer exists. They erased it from the dictionary. So it's no longer here. The Syrian interconnection with the 230 kilovolts no longer exists. When you go to the old reports about the electrical power in Jordan, you will see the 230 volts, and it was part of the high voltage, not medium voltage, not extra high voltage. So in the past, when you look at the Jordan electricity, you will see high voltage levels 132 and 230 kilovolts, while extra high voltage 400 kilovolts. That was in the past. While nowadays, the 230 is no longer exists. So they erased it. So therefore, it has been erased from the map. There is no Syrian connection company with 230 Syrian interconnection power from 230 kilovolts. So the only interconnection with Syria is the 400 kilovolt from North Amman, Shamal Amman, in Shafa Badran area. It goes towards Syria through Aswaida. So this line is, in our side is ready. Everything's fine, no problem with that. But it is turned off since the Syrian conflict. It's been turned off since 2011. So what's the problem? From Jordan side, there is no problem. The problem that they have in Syrian parts, especially in this area. In this area in Suwaida, Muhafat Suwaida. And as we know, there is still a lot of troubles in regarding to the safety in Suwaida area. So there is a lot of work to do to fix the problem there. Jordan offered help, but this area is still unstable. So we couldn't supply power to Syria yet. It's not ready yet. But our target is to make it as soon as possible. Once everything in Syria being solved, when everything is fine, then we can sell power to Syria. And our target is not only Syria. So there is another connection between Syria to Lebanon. So our target is to sell power to Syria and Lebanon. And we can do that. Yes, we can. But the problem is just with Syrian borders here, especially in Suwaida area. Once they figure it out, once they solve their problem, then we will be ready to sell power to Syria and Lebanon. But right now, what we have with Syria, but it's not energized, it's out of service, then we can say الربط الأردن السوري, or the interconnection between Jordan and Syria, is not energized, not in power, not in service yet. It was in service before, but now, no. The other thing, the Egyptian Jordan interconnection. The Egyptian Jordan interconnection, there is, in Aqaba, there is a substation here that there is a terminal tower that goes through a submarine cable. That submarine cable, I believe it is around 20-ish kilometers. So it's submarine. That goes between Aqaba to Taba. City in Egypt called Taba. It goes to Taba. It was as a submarine cable bahri. So it will be connected to Taba. This interconnection has 400 kilovolts in Jordan. In Taba, there is a substation, and there is a transformer, step-up transformer, that's converting 400 kilovolts to 500 kilovolts. So yes, the interconnection between Jordan and Egypt is 400 kilovolts, but with Egypt, there's a substation there that's converting this to 500 kilovolts, and it goes towards Sinai and towards Egypt. So the interconnection between Jordan and Egypt is still in service. It is in service, and it's very beneficial for us. And there is a tariff between Jordan and Egypt. There is 3 tariffs, depending on peak tariff or off-peak tariff, or we call it, I would say, like, they call it in a different way. They call it morning tariff, evening tariff, and night tariff. And of course, the night tariff is the cheapest. Evening tariff is the most expensive. So the thing here, in the interconnection, what's the benefit of interconnection? Which is basically, assume you have a neighbor and you are running out of, for example, sugar or rice, then ask your neighbor, I need help, please give me some. So he'll give you some. Then instead of going to the grocery for just buying that specific thing, then you can just take it from your neighbor. Then if your neighbor needs something, they will take it from you. Then, but at the end of the month, they'll you will look at the difference and look at, I mean, how much money do you need to pay. Then you can just like pay it with each other, or just exchange the money or exchange the energy. So the thing here, when you have neighbors or you have friends, when you need something, they will help you. That's the good thing about the interconnection. If we have, if Egypt needs some power, we will give it to her. If we need some power, we will buy it from Egypt. That's the thing. And with this is very strong relationship. The electrical relationship between Jordan and Egypt is very strong. And I mean, we like each other. We love each other, like, because we are doing, I mean, everybody's doing their job, and we used to help each other, and they are very helpful. So again, we have a very, I would say, like a very excellent relationship with Egypt in terms of power. And we used to do, I mean, monthly meetings with them. Then, I mean, they are very helpful. So that's great. We are very, I mean, I'm glad about that. And we hope the electrical power company with Syria being being recovered, so we can sell power to Syria, and we can make a bi-directional power supply with Syria. Now, when you look at it again in Jordan, we have only two voltages. I mean, with regarding to the transmission, 400 and 132. The 230 volt is no longer exist. 230, we already, as I said, like, it has been dimensioned and there's no longer exists. Now, the other thing, there is other interconnections, but in my point of view, it's not considered as interconnection. It's considered as a customers. Where are they? In Sweme. Here, there is a substation in Sweme, and power line goes from Sweme to Jericho in West Bank in Palestine. Jericho and Jerusalem. Which is Ariha al Quds. But there is a substation in Ariha, Jericho, that supplies Ariha and al Quds. So those are can be considered as customers, not as interconnection. The meaning, the real meaning of the interconnection is to have power exchange. Buy power and sell power. Buy, sell, whenever you need. While with Ariha and Al-Quds, Jericho and Jerusalem, we just sell power to them. We are not buying power at all. They will not give us power. It's just a one direction from Sweme toward Jericho and toward Jerusalem. Just one direction. So some people call it interconnection, but I believe it's not interconnection. Interconnection is just bi-directional. But this one is a one directional. It's not considered as interconnection. But I would say, like, if you hear somebody say it's interconnection between Swame or between Jordan and Jericho, Jordan and Jerusalem, yes, we have this, but they are just customers. They are not, I mean, interconnection. So what's the voltage? It's associated with 132 kilovolts. It has been established to be like that, but right now it is energized based on 33 kilovolts, not 132 kilovolts. That's the thing. Then the thing here, it has been energized on 33, but when you go to the read the data sheet, or when you read some information, you will see it is 132 kilovolts. But again, it has been established, has been built up to be based on 132 kilovolts, but it is not. It is with 33 kilovolts. Right now, with 33 kilovolts, but in the future, they might switch it to 132 kilovolt. It's very easy to switch it to 132. I mean, in our side, but in Ariha side, it's not easy. But in Jordan side, it is very easy to make it 132 kilovolts. Maybe later in the future, I mean, if they decide to make it 132, we can do it in, I mean, easy in our side. Again, in Ariha side, it's not easy, but in our side, it is easy. So again, this is 132. And there is, again, this is not considered as interconnection. The interconnection, the only interconnection that we have with Egypt, with Syria is out of service, with Ariha and Jerusalem, it's not, it's just they are customers. And the other thing with Iraq, I mean, you might hear that we are supplying Iraq. We are not supplying power to Iraq, we are supplying to Tarbil. Here, the border, Tarbil area. So Tarbil, we are selling power to Tarbil. Just selling power to Tarbil because here there is no, I mean, it's very gap here in the desert, so there is no, I mean, population, no electricity. Then we are just selling power to Tarbil. That's what we have. Then Tarbil, it's considered as a customer, not considered as interconnection. There is no bidirectional power. We don't take power from Tarbil to Jordan. So that's why I would say it's not considered as Jordan Iraqi interconnection, Jordan Iraq interconnection. It's considered as selling power to Tarbil alone, not to Iraq, just to Tarbil. The same thing with Ariha and Jerusalem. We are not selling power to Palestine. We are selling power to only Ariha and Jerusalem. Okay? So, in summary, I would say interconnection, international interconnection, we have with Egypt, with its in service, Syria, out of service, Palestine, they are customers, again with Jericho and Jerusalem. As a shortcut, we call it Jericho. Then we have with Iraq, but they are not considered as interconnection. It's considered as a customer. Which is basically Tarbil. Okay, does this make sense? Any question? So this is considered as international interconnection. With Tarbil and Jericho, yes, it's international, but it's not interconnection. It is just, they're just customers. All right, let's talk some about Sitco. Sitco, شركة توليد الكهرباء المركزية. It is, I mean, there are a lot of parts on it. So it was the old power unit generation, thermal power generation units. When they separated from GEA, they put it with Sitco. So there are, I mean, a lot of things. There is محطة إرحاب, and there is محطة العقبة الحرارية, محطة الإبراهيمية, محطة الريش الغازية, محطة حوفا, but it's no longer in service. I think محطة الحوفا now it's out of service. So it used to be old power thermal units associated with Sitco. That's the thing here, like محطة حوفا again is no longer exists. So now we have 4 units. Also there was in the past 6 in Zarqa, محطة الحرارية في الزرقاء. But it is out of service as well. So it's no longer in service. So it is the thing here, they don't, I mean, it's out of service, then they don't do anything new. If we need to make anything new, we will let the private sector do it, not the, I mean, the governments. So I'm not sure if they have a future plan to expansion for Sitco, but that's what they have right now. SIPCO, محطة توليد السمراء، شركة السمراء لتوليد الكهرباء، سمراء Electric Power Company, or sometimes we call it SIPCO. Sometimes they call it SIPCO, Samra Electric Power Company. Sometimes in the old, they used to call it SIPCO, which is Samra Electric Power Generation Company. That's why we call it, just add the G means generation. Okay? Right now, I believe they are calling it SIPCO, no longer SIPCO. So right now, we are using this, use this, SIPCO. It's owned by the governments, and they have, I mean, multiple steam. So we have the single steam, and we have the combined cycle. And keep in mind, they have, I mean, there's a steam and there's the gas, where we work the gas, single cycle and combined cycles. And here is like the capacity for the summer, around 1.175 megawatts or 1.17 gigawatts. That's the capacity for that. Then here in SIPCO, you can, or like those again, like the government is controlling this, owned by governments. What else? Let's talk about the ERC. ERC هي تنظيم قطاع الكهرباء. Again, that was in the past. Now it's called Electricity and Mineral Regulatory Commission. EMRC. Right now it's called EMRC. Uh-oh. Okay. Right now it's called EMRC, while in the past it was ERC, and was established in 1998, ERC, and I believe in 2005 or 2008, I'm not sure, they just make it to be EMRC, so they just swap it. So again, right now it's called EMRC. They are to ensure the right of the customers and resolve any complaints that occur between the customers and the electrical power company. And if there's, for example, there was a conflict between NIPCO and IDCO, EMRC, they will take care of it. They will solve this issue. If there's a conflict between the customers and the distribution company, EMRC will do the job. They will solve the problem. If there's a conflict between the generation and NIPCO, also EMRC will try to solve the problem. Now, the other thing, let's talk about Irbid District Electric Company, which is Karuba Irbid, or IDCO. It was established in 1957, and it was supplying Mafraq, Irbid, Jarash, and Ajlon, and some part of Balqa, just some part, and which is basically 26% of the customers from Jordan based on IDCO. So IDCO covered 26% of the load of the customers, 26%. And this company has been privatized, and it is owned 55.4. It was owned by the Kingdom Electricity Company, which is owned by the Capital Dubai Company. Capital Dubai Company, they are owning this IDCO. It's owned by IDCO. The Jordanian Electrical Power Company, it's also a private. It was established in 1938. Then JIPCO is responsible for distribution the power for the middle sector. In the middle sector, which is basically Amman, and I would say the Madaba. What else? The Zarqa, and I would say Balqa, including salt, etc. So the thing here, it covers 66% of the total customer in Jordan. 66%, which is very big size. However, in IDCO, 26. So we have 66 and JIPCO, and 26 with the IDCO. So 6, 12, 98% of the electricity, the customers will be with JIPCO and IDCO. Then 8% will be with IDCO. IDCO, شركة توزيع الكهرباء. So it was established in 1998 after the GEA has been diminished. Then the thing here, it includes the south region, العقبة, معان, الطفيلة, والكرك. Not only that, also some areas where the load is light, like Azraq, Safawi, Erweshid, Risha, middle section, Jordan Valley, from Al Hamme until the Sea, middle region. So all of them, they are also part of the IDCO, and this company has been privatized 100% by the KEC, which is by the Dubai company, Dubaian company. Here is like the map. You see like the map of IDCO, IDCO, and JIPCO. You see how is the company. While again, like 26 of the customers with IDCO, 8% with the IDCO, and the JIPCO, I believe, 66%. Okay, even though IDCO is like the largest in size, I would say like the number of customers and the electricity consumption is low compared with Amman and Irbid. Here is like some data about the peak loads for interconnected systems with the system and the available capacity. So in 2024, the available capacity about 4.4 gigawatts. Here's the mega in megawatts. In giga, 4.4 gigawatts as a conventional, as a renewable, 1.6 gigawatts. However, in peak load, the maximum 4.1. That was in 2024. Here is some data about in gigawatts hour, how many energy being purchased, how many being sold, how like wheeling energy, how about the losses? The losses are around 1.76%, which is a decent number. And there is like the how many kilometers, the length of the transmission line, 400 kilovolts, and the length 132 kilovolts. Almost no changes, a little bit of change. About the installation capacity for the substation, 132 and 400 kilovolts, you can see the capacity is very big, more than the generation capacity. And that's normal because we need to make sure everything's fine. And the fixed assist, how much the total cost? 607 million Jordanian dinar, or 0.6 billion Jordanian dinar. That's the capacity, I would say, which is almost 1 billion US dollar. That's the fixed assist. Peak loads, we can see like by growing the demands, you see, realize that the peak loads getting high. And they look at it morning peak load, evening peak load, and minimum loads. So we can realize that the minimum loads is increasing as well because there is a large demand. And the morning and evening loads are increasing as well. But there is, I mean, maybe between 2023 and 2024, there is some slight difference. The reason I believe because it was maybe after the COVID and there was still time for recovery, while in the right now, in I believe in 2024, 2025, I believe it reached 4.6 or 4.7 or 4,700 something, 4,700. So it was very large value. And the peak, I think it was in August 2025. I remember these days, the amount of energy was very the borderlines of the capacity of Jordan, because the capacity of Jordan can handle 4,850 at that time. I believe now it's 5,100. But in that time, in last August, it was 4,800 something. So at that time, it was very close to the peak. So at that time, if it's reached that value, it will not be sufficient to supply power because all of the capacity has been filled. While right now, I believe it's 5,100, and there's still more willing to expand more and more and more. Here's the load curve. We can look at the load curve like this shape. So you can see there is a minimum load. There is a maximum peak in the morning, peak in the afternoon. So when we look at it, we realize that in the peak, we cannot turn all of the generation units at the same time because we didn't want this to be extra generation. If there's extra generation, how is the extra generation will be understand? How can we understand this extra generation? The generators start to accelerate. They will accelerate faster. The frequency will be unstable. Then we need to reduce the frequency, or to reduce the frequency, or reduce the generation to make it stable. So we can say during the peak times, we cannot turn on the turn on a new thermal power generation units. The only thing that we can do is to turn on some peak units, which is like the units that are working on diesel. Here's like, again, the load curve, like there's two peaks and there is a minimum load. The other thing that when you look at it, look at the thing in gray, this is the renewable energy or the photovoltaics. The disadvantage of the photovoltaics, which is basically the peak generation of the photovoltaics, different than the peak of the load curve, which makes it here and getting the steam cycle getting narrower. the steam cycle or the steam turbines or steam generation are basically, or I would say like the thermal substations, no matter if they are gas or steam, the thermal substations, they are very difficult to increase and decrease the amount of generation power. It's very slow. It might take hours to turn on and turn off. So, which is something will be infeasible in case of there is a peak load. That's why when we make a load curve, here is a load curve. Here's the load curve. We said that we need to split it into different things. So during this, we will turn on the thermal power plants. We're always on thermal power plants. While here, we can turn on peak units. They will work only for short period of time. Peak units, the units that are working on diesel, since they are working on diesel, they were very fast. They can be turned on and turned off within a few minutes, maybe 10 to 15 minutes. They will be turned on and turned off. So which will make it very good to be working on during the small peak time. Here, the short period peak, maybe it can be 1 hour or it can be 30 minutes. So these peak units can be turned on and turned off easy during this peak time. But the drawback or the disadvantage of that is because it will cost a lot because it's very expensive when you generate power from diesel. It's more expensive than generating power from thermal units. Of course, thermal units is more expensive, it's more cheap, way cheaper than the peak units. But since the load behavior curve like this, then we have no control. We need to turn on the backup. I mean, I'll call it like the fast units. The other thing, again, the drawback of the renewable energy is the renewable energy peak different than our peak. So, which is narrower the thermal units power plants. So, during the peak period here, the maximum peak period, there is no renewable. So the gap will be very big for the peak units to turn on, which means add more peak units, pay more money. That's the drawback of the renewable energy, especially the photovoltaics, because the peak happens around at sunset. At sunset, where there is no photovoltaics. Peak happens. Before sunset, there is a photovoltaic supply power. So reduce the amount of power that we need to supply to provide for the customers, which is, I would say, okay, here can be good, but it's not 100% good because this means the thermal power units, they are turned off. And here during the peak, you cannot turn them on because it will cost a lot of money. I mean, not cost, I mean, need some time to cool down and turn them on. Then how can you supply power during the peak, then turn on the more expensive unit, which is called the diesel generation units? Okay? Here is the capacity of the generation power plants, the overall capacity from hydro, wind, solar, renewables as a sum, and traditionals. Traditionals, we mean like the thermal power units. Not only thermal, and I would say like the peak units, which is the diesel, thermal and diesel units. Okay? So we realize that there is, I mean, a very big value in the renewable, while the traditional also keep growing. So our target is to make the renewable shall not exceed. It will be less or equal to 30% of the traditional. That's our target. We don't want this to exceed more than that. Because why we don't want that? Because of the load curve behavior. As I said here, the peak of the renewable different than the peak of our system. So if it is more than 30%, we will struggle on maybe the peak unit might not be enough to supply the load during the peak units. So there will be a big problem. Installed capacity, again, we have the Jordanian electrical interconnection. It can handle like the submarine cable up to 550 megawatt. This is something great, and it's very beneficial to Jordan, especially when there is a power outage in one of the power generation units, we will take power, we will buy power from the Egypt to supply the missing power, and then once everything go back, that's fine. However, even though if Egypt was out of power, we're still capable of supplying power to Jordan, because we can turn on the peak units or turn on some other power generation units. While when we turn on the power generation, while if the I mean the P you can turn on the power generation units, but it can cost a lot. So that's why sometimes buy power from Egypt is cheaper than turning on some power generation units. So we are looking for the cheapest options, but sometimes we like the Jordan interconnection. The Syrian interconnection, there is no Syrian interconnection. Again, it's out of service. The Jordan Palestine electrical interconnection, Jericho, which is in Ariha, on the Jerusalem. There is again it's mentioned under 132 kilovolt, but again it's not 132, it is 33 kilovolts. Then the last one, Jordan Iraqi electricity. Again, it is not interconnection with Tarbid, it is just like they are customers. So even though they are considered here their interconnection, by this is not interconnection, this is not interconnection, this is out of service. The interconnection that the only interconnection that we have is the Egypt interconnection through submarine cable. Okay, any question? Okay, I believe this is the end. Please, if you have any question, I'm happy to. Okay, now we are done with this chapter. Next lecture, we will go to the next one, which is transmission system and overview planning. That will be our topic next lecture. Recording.